All right, hello and welcome everyone to Dynamic Workloads at the Right Price. We're going to be talking today about Cloud Run and GKE and how they can help you scale your business. I'm Caslin Fields, and I'm a developer advocate at Google Cloud, where I focus on Google Kubernetes Engine and open source Kubernetes. And it's my birthday, so thank you for coming to my birthday party that Google's throwing for me. Thank you. We also have today my teammate, Luke Schlangen, who is also a developer advocate on GKE. And we're very excited to have Andrew Moreland from Chalk. And they're going to tell you a little bit, he's going to tell you a little bit about Chalk's story of how they got their business going and scaled with Cloud Run and GKE. So to start off today, we're going to talk about scaling a little bit and what we mean by scaling. Then we're going to hear Chalk's story about how they've been using Cloud Run and GKE. Then I'm going to go over the essentials of what you should know about Cloud Run and GKE and kind of when to use them. And we're going to talk a little bit about the Google for Startups Cloud program. To start off, let's go over what we mean by scaling. Essentially, scaling is all about making sure that your business has what it needs in order to meet the demands that you're under. So Cloud Run and GKE are two tools that Google Cloud provides that are meant for handling scale. They have really interesting auto-scaling capabilities so that as your demand shifts and changes, you're paying for the right amount of resources to meet the demands of your business. Both Cloud Run and GKE have a variety of features intended to make sure that your workloads are being run in a highly available fashion. They're also, again, a lot about scale. So making sure that as your demand goes up, you get more resources. As it goes down, it also scales down so that you're not paying for more than you need. It's about enabling your workloads. So whatever business you may be running, whatever programming languages, whatever kinds of applications you may need to run, Cloud Run and GKE make use of container standards to make sure that you can run them. We'll talk a little bit more about that later. And I've been talking about responding to demand. Both of these have a variety of features to help you do that. But first, let's hear Chalk's story from Andrew to give you a sense of how this works in the real world.
Thank you, Caslin. Am I coming through okay? All right, so my name is Andrew Moreland, and I'm one of the co-founders of Chalk. At Chalk, we help companies in industries like banking, healthcare, and e-commerce use machine learning to solve problems like credit underwriting, or emergency room triage, or product recommendation. And the thread which ties all of these use cases together is the problem of getting the right data in the right place at the right time. Our customers need to integrate and transform data from a variety of data sources, so things like Postgres databases, or BigQuery, or PubSub, or Kafka, or you name it. All sorts of things that they need to tie together to deliver data to their models. And today we're going to look at a quick demo of how Chalk uses Cloud Run and GKE in order to execute workloads with dynamic resource requirements in order to serve these customers. We're going to focus on two of the key workflows in machine learning. The first is the problem of online inference, so the problem of getting a single vector of features really fast to a model to make a prediction right now. And the second problem we're going to talk about is the problem of getting a big table of data to go ahead and train a model. So zooming out for a moment, let's imagine that we're a bank. I don't know how we would be a bank, but let's pretend we are. And suppose we want to do a credit underwriting model. Fundamentally, what we want to do is take a huge amount of data about individuals and their financial behaviors and crunch that down, distill it into some sort of machine which can predict the creditworthiness of a particular person. So we want to understand, can this person pay us back? Do they want to? Will they? And the way we're going to do that is we're going to compute what machine learning practitioners call features. A feature is just a fancy word for a data point that goes into a machine learning model. So a thing like a person's name or their favorite color, their income, how much money they spent on burritos in the past 30 days could all be a feature. But today we're going to focus on features that are derived from financial transactions, which is a rich source of data for underwriting. So zooming through this slide, let's take a look at some code. So on the screen right now is what we call a feature schema. So a feature schema basically just has the names and data types of the features that we want to compute. It's fairly straightforward, but here we're describing the features of a transaction object. So a transaction has an amount, has a bunch of other data, and it has a description, so the thing that shows up on your bank statement. But the schema is not the interesting thing about what we're doing today. Here's an example of what we call a SQL resolver. A SQL resolver is one node in a big graph that we're building up, a compute graph, which we'll use to derive the features that we're going to use for our models. That SQL resolver, which was there for a moment and is now gone, is not very complicated. It's basically just mapping data from an underlying SQL table into the feature schema we just defined. But once we've defined this kind of foundation, we can start to do things that are more complicated. So what's on the screen right now is what we call a Python resolver. A Python resolver is a more complicated construct, which is also part of that same compute graph. Using the type signatures of its argument list, it can declare dependencies on features that we've already computed, and it can tell us what it's going to produce. Ultimately, what we're going to take in here is the amount of a transaction and the normalized description of a transaction, which is produced by what we call an upstream resolver, a resolver which has already gone through and cleaned up that string that appears on your bank statement. And then it's going to tell us whether that transaction corresponds to a telecom vendor, so maybe like a cell phone bill or something like that. And pausing for a moment, why are we doing this? Like intuitively, why do we care about this operation? So if you look in the problem of fraud, if you look at the transactions that are in a bank account, intuitively, if the transactions correspond to normal everyday people type things like groceries, gas, mortgage, in the Bay Area probably rent, a cell phone bill, it's more likely that that bank account corresponds to a normal everyday person, not someone who's trying to steal money from us. On the contrary, if we don't see those sorts of patterns in these accounts, it's probably a big sign that this account could be made by someone with a false identity who's trying to construct a situation where they can steal money from us. So it's a really powerful signal to feed into our predictive models. And once we've defined this Python resolver, we can go ahead and query it. So on the right-hand side, you see the output of running a query command. So what happened basically is we sent an API request off to Chalk's server, asked for two features, the is_telecom feature and the normalized description feature. And Chalk returned its output. And in particular, we noticed that this arbitrary transaction was classified as not a telecom transaction, which is a little odd because we see Verizon bill payment in the description. So this raises kind of 2 points. The first is that data quality is really important. If you have bad data, if you're telling lies to your models, they're going to tell lies back to you. So one of the things we want to focus on is making sure that we have really high quality feature pipelines to deliver correct data to our models so that we can make high quality predictions. And that's one of the problems that Chalk is really engineered to solve. And the second thing here is that things go wrong. If feature pipelines are rigid and hard to change, it's really hard to get that high quality of feature output that we ultimately want to deliver to our models. So Chalk is set up to make it really fast and easy to flexibly iterate on these feature definitions. So on the left, we've jumped to the definition of one of those constants that was in that Python resolver, basically a list of keywords that we're checking to see if they appear in the transaction description. And what we can do using Cloud Run, basically, is add a new constant to this list of constants, and then type chalk apply, wait about 100 milliseconds, and then the new pipeline is live. And that leverages the ability of Cloud Run to deploy tons and tons of pipelines really quickly. And as soon as it's deployed, it's ready to be queried. So we can see the change we just made and see its impact immediately. So this gives us kind of like a hot reload, like modern web development experience, but for data engineering pipelines, which traditionally have been like fairly inflexible. They tend to have lots of global state. They're slow to change and hard to understand what's going on in them. So we think this is a really amazing developer experience. And it's made possible by Cloud Run because basically every time that a user makes a code change, and we can set like a watch command up to do these automatically, we can ship off a new revision to Google, and it becomes immediately available for querying, but if it's not queried, it doesn't cost anything. It scales entirely to 0. And at the same time, if it is queried a lot, it can scale basically instantly up to 10,000 queries per second. So you have all these different snapshots of your feature engineering pipeline, all these different kind of forks and points in time, which you can choose to flexibly move between and promote in order to have that modern web development experience for data engineering. So this is the first workflow I wanted to talk about, online inference. But the second workflow is also really interesting. The second workflow is the problem of getting training data. So instead of talking about a single feature vector, we want to talk about many, many, many feature vectors. So a big table of data which we can use to go and train a model. So instead of running a query, we're going to run an offline query. Make sure the video goes. All right. So this offline query, instead of taking in a single transaction ID, takes in a big vector of transaction IDs. And you can pass in a bunch of features you want to know about these transactions. So not just from one data source, we can blend data from databases, from computed features, from streaming sources, from batch sources like BigQuery, and synthesize it into a unified table which you can then pass off to whatever you want to use to train your model, like scikit-learn or whatever you'd like. We're largely agnostic to that. And what's going on under the hood here is when you submit that query, Chalk's query planner sizes the query, understands how many resources you need in order to execute it, and then spins up the right size containers in Google Cloud, in Google Kubernetes Engine automatically. So we basically automatically understand how many CPUs and how much RAM you'll need in order to compute this training set. We make sure we have the right containers. If we don't, we spin them up. We shard the work, distribute it out, and get back the results all in a couple seconds. And GKE makes it possible, or GKE Autopilot in particular makes it possible for us to have this really amazing interactive query experience across data sets that have millions or billions of rows, while basically paying for only a few seconds of compute, because we can spin stuff up and spin it back down. And without Chalk, without GKE Autopilot, in order to get an experience like this, we'd often have to leave a big Spark cluster laying around all day, paying for tons of computers which probably aren't doing anything in order to make sure that our data scientists have a really good interactive experience. So fundamentally, the combination of Cloud Run and of GKE, in particular Autopilot, gives us the ability to offer a really incredible developer experience, kind of that modern web development hot reload experience for our data engineering pipelines, all at a really affordable price point. So thank you for having me up here, Luke, but I wanted to talk about one last thing, which was the transition from Cloud Run to GKE. So you might be thinking, Kubernetes, hard, it takes a lot of time to switch to. But fundamentally, Cloud Run and GKE have approximately the same configuration API under the hood. So when we needed to make that transition from Cloud Run to GKE, as our business scaled and our workloads grew larger than we can fit in a single instance, we were able to make that transition in just about a single day. So it really isn't so bad if you do need to make the switch. So thank you.
So in order to get our application out into the world, if that's what you're looking for today, if you're a web application developer like me and you just want to get your application into the world, this is the fastest way to do it. It's a single command. If you have gcloud installed, if you have a container image already running, already in existence, this is the fastest way to get out there. And maybe you don't have a container image already in existence. You can use source code to do this as well. So you can take your source code, throw it to Cloud Run, and if you have a Docker file, it can go through that. If you don't have a Docker file, it can guess. It can make a best effort with Webpacks, and it can put that together for you, which is really phenomenal. So Cloud Run, scale with Cloud Run. There is a point where you'll move from Cloud Run to GKE potentially, but I want to debunk a really common myth here, and that is that it doesn't handle scale well, because Cloud Run can handle any amount of scale. So let's talk about Cloud Run here. 5 bullet points that I want to run through before I get to that headline of why you might actually be moving from Cloud Run to GKE. So the first, any language, any binary, any library, this is true of both Cloud Run and GKE, and that is because they are both using that containerization fundamentals, right? We're taking our code, we're putting it into a container, and now we can run it a whole lot of different places, which leads to Andrew's point about how when and if you decide to move from Cloud Run to GKE, you already have this fantastically containerized application, and you can move from one to the other. You just put the image in your YAML file for GKE and say, this is the same image that we just talked about on the previous slide. So Cloud Run uses containers, leverages that power. The reason I love it as a web application developer is it's fully managed. After that line we ran, it's ready to go. It's up and running, and it does auto-scaling for us. So it's going to automatically scale all the way up to what we need, and it's going to scale all the way down to 0 when we aren't running it. So if you want, you can set limits to that. So say at most you only want 10 instances, and at a minimum you will always want to have one ready and up and running whenever you need it. You can do that within Cloud Run. So there is a lot of potential within the bounds of Cloud Run, and that includes you only paying for what you use to the nearest 100 milliseconds. So there's a fantastic demo. We'd recommend you check out Innovators Hive. You can see Cloud Run in real time scaling up and down, and you'll notice that while pods are still ready at times, you're only paying for the ones that are receiving requests. So you're not paying when the pod is necessarily running in the background. We are scaling it for you up and down. So this is a phenomenal place to get started and doesn't prevent you from moving on to other things in the end. Okay, so I buried the lead here and I promised that I would get to it. Why might you move from Cloud Run to GKE, like Andrew said? So again, to hammer home the point, it's not based on scale. It's not the number of requests you receive because Cloud Run can handle it. Whatever you want, however many requests you're sending toward your application, Cloud Run can handle it. So when do we move? So Andrew pointed out the first example that I'm going to use, which is instead of requests, you want to scale based on something else. So in his case, in machine learning, not every request needs the same amount of compute. Not every request needs the same amount of memory. And he wants to scale precisely based on the query. So he has a query planner. He knows exactly how much memory, exactly how much CPU he needs in order to run those queries. That's what he's scaling based on. So he is looking at something like GKE. The other example, we see something very often where people don't have a single application. So far we've talked about services where it's just a single service, a single backend, and you're sending requests to that single backend, and there Cloud Run can scale up and down to meet that demand. But once your application architecture starts to look like this, if your architecture diagram isn't a single box, and you need a whole lot of interactivity between those different containers, you can orchestrate that with Kubernetes. And that's another good sign that it's time to move to Kubernetes because Kubernetes can handle that well. But of course, there's the old adage, with great power comes great, oh, come on. With great power comes great amounts of YAML. Yes, we all said the same thing at the same time. Fantastic, thank you so much. And with that terrible dad joke, I'm gonna hand it off to Kaslin.
So now we're going to dive more into GKE. And I love talking about Kubernetes, so thank you for letting me talk about Kubernetes on my birthday. So as Luke was saying, GKE has a lot of potential for helping you to manage more complex architectures. It provides a way for you to have finer-grained controls. It has a lot more buttons and knobs for you to use when you have those more complex architectures or those workloads that have very specific requirements. Kubernetes and Cloud Run and a lot of cloud tools are really about distributed computing. The cloud gave us the ability to have a whole lot of computers at our fingertips at any given time. In Cloud Run, you're abstracting away a lot of that complexity and just saying, hey, what is the application that you need to run? We'll worry about the back-end stuff for you. Kubernetes allows you more of that control to say, here are the machines that are underlying my applications. Here's the things that my applications need from those underlying machines. And a great thing about Kubernetes is it allows you to tell it these things in a declarative manner. So you tell Kubernetes, I have an application, it needs GPUs, it needs SSDs, make sure that that's happening for me, and keep this many copies of it up at any given time, for example. You do all of this with YAML, as Luke was saying. So that's declarative application management with Kubernetes. As we were saying, another reason that folks move to GKE is you do have more control over the types of hardware that you're using to run your applications. And as we've been talking about, it enables more complex architectures. Kubernetes has the ability to, when you're running many different microservices within Kubernetes, it has special tools to make sure that they can interact with each other and not things that they're not supposed to be interacting with. So it's very good at enabling complex architecture. But we're here today to talk about scaling. So there are 4 dimensions of scalability that you should know about if you're considering using GKE. The top 2 on this diagram are about workloads. The bottom 2 are about infrastructure. The 2 on the left are about creating more or fewer of something. That's called horizontal autoscaling. And that's usually what people think about when you think about scaling workloads or scaling Kubernetes. The 2 on the right are what we call vertical autoscaling. So the vertical pod autoscaler is going to be helping you to set the requests and limits on your workloads. So telling us how much CPU, how much memory that workload actually needs. Node auto provisioning is about choosing the right machine sizes that can give you those resources that you need. So horizontal pod autoscaler is going to be creating more copies of your workload, or fewer, and cluster autoscaler is going to be creating more machines, or fewer machines. So all of these work together. And earlier in Chalk's story, we heard about GKE Autopilot specifically. So in GKE Autopilot, it's kind of a world between pure Kubernetes and serverless, which we were talking about with Cloud Run. In the case of GKE Autopilot, we set up your cluster with enough machinery, enough resources to meet your workload's needs based on those resource requests and limits. And we essentially call it nodeless Kubernetes. What's happening behind the scenes in Autopilot is we've set up the cluster autoscaler and the node auto provisioning for you. So we're configuring all of the infrastructure underlying your workloads for you. But you still have the ability to configure a lot of things about how your workload runs. You could set up the horizontal pod autoscaler and the vertical pod autoscaler. You can tell us that you need GPUs. You can tell us that you need SSDs. You have a variety of tools available to you to make sure that your workloads are running the way that they need to, using Kubernetes to have the machines underlying it that you need. And that's all I'm going to cover for you today about GKE itself. I hope that you learned something new and something interesting today in our talk. These are the things that, if you took away anything, I hope it'll be one of these. First off, as we heard in Chalk's story, that getting started with Cloud Run and GKE isn't so bad. They can seem very scary at first, but once you start getting into them, they work very well together, and Cloud Run is often cited as being particularly easy to get started with. So both of them really are not so bad. Cloud Run, in particular, is great for simpler architectures and standalone services at any scale. So it's not scale that keeps you from running on Cloud Run, but perhaps a more complex architecture or specific hardware needs. GKE provides greater configurability for more complex architectures. And whichever tool you choose, we hope that you've seen throughout Next that Google Cloud has the tools to support your journey to scale. And we would like to bring Andrew back up to the stage to talk about where they're going with their business right now.
Thanks, Goslin. Yeah, I'm very excited to announce the release of some new functionality for Chalk. So we're releasing Chalk Branches, which is that functionality you saw back in the demo earlier, where you can make a new deployment in about 100 milliseconds. So it gives you that really fluid developer experience. And we've also, as part of this release, built the capability of defining features and resolvers in Jupyter Notebooks. So the data scientists don't have to use an IDE if they don't want to. They can just try out new features and new pipelines right there and then deploy them. And I think one thing that our customers ask us often when they're considering using generative AI is, what should we be worrying about? How should we be thinking about it? And the thing that I always tell them is that these models are very powerful. They're super fancy. But ultimately, if you give them bad data, they're still going to produce bad output. I think a lot of people have shown that in a bunch of quantitative ways. So the old adage, garbage in, garbage out, is still true. And a last note, we've been part of the Google for Startups Cloud program for quite a while now. And obviously the credits are great, but one of the other things which is maybe overlooked about the program is the access to technical experts. So as we were using Cloud Run and using GKE, we got a lot of help from some fantastic folks at Google, so I wanted to say thank you for that.